So today's lesson, guys, we're going to talk about angles formed by parallel lines and transversals. So we're going to do some defining of terms first. So parallel lines are two lines that do not intersect and have the same slope. So these are parallel lines. They literally look like they draw an equal sign somehow. Could be horizontal, could be diagonal, but they're two lines that actually will never touch each other. Then a transversal is a line that intersects two or more coplanar lines at different points. So I'm going to draw a transversal on these two parallel lines. So that right there is a transversal. It intersected the pair of parallel lines at two different points, right? A linear pair is a pair of adjacent angles that form a line. So this is the line, right? And then when I draw an angle like that across that basically creates two angles, or draw a line that creates two angles, then these two angles to the left and to the right are what we call a linear pair. And we know that those are always going to add up to be 180 degrees because they're supplementary, like we dealt with yesterday. Vertical angles is a pair of non-adjacent angles formed by the intersection of two lines. So this is when we have two angles that are opposite each other, right? So that would be like this angle. Okay, pen, work. This angle and this angle, or the top angles. They're opposite each other, right? So directly opposite each other. Those are vertical angles. We're going to talk about the relationship of those. And obviously, hopefully you can tell that these opposite angles here would be congruent, right? And those two opposite angles would be congruent. Corresponding angles are two angles that have corresponding positions. So they are the same side of the transversal and the same side of the parallel line. So what does that mean? So that means, for example, I would be to the left and to the left and above and above. Y'all see that? Left of the transversal and above the parallel lines. Or I would be below and to the right and below and to the right. Those are corresponding positions, okay? So let's go on to the next one. Then alternate interior angles are two angles that lie between the two lines and on opposite sides of the transversal. So between the two lines and opposite. So there and there would be a pair. Sorry, there and there would be a pair of alternate interior angles. And notice they're congruent. And then here and here would be another pair of alternate interior angles. And they are congruent, okay? Then we have alternate exterior. Makes sense, right? Alternate sides of the transversal and outside exterior of the parallel lines. So that would be like here and here, or here and here, okay? Then the last one is same side interior. And then we should have same side exterior too, and I don't know why it's not up here, but I'll fix that in a second. So same side interior, so same side of the transversal and inside the parallel lines. Those obviously are not congruent. They are supplementary. And then here's another pair of same side interior angles, okay? And our last one is same side exterior angles. These are two angles that lie outside the two lines that are parallel, right? So outside and on the same side. So notice again, those are not the same angles. One's obtuse, one's acute. And here's another pair of same side exterior angles, okay? And we're going to talk about what all that means a little bit more in just a second, okay? All right, so now, this is identify each pair as alternate interior, alternate exterior, corresponding same side interior. Alternate interior, alternate exterior, corresponding same side interior, linear pair, and vertical angle. So let's look at 1 and 2. 1 and 2. So what do you notice about 1 and 2? There are two angles that form a what? Do you see that right there? A line, right? So this is a linear pair. Okay. Now we have 1 and 6. Those are opposite of each other, right? And notice that linear pair, when we add those two angles together, that would have been 180 degrees. 1 and 6 are both acute angles, and so they are going to be congruent, and these are vertical angles, right? Because they're opposite each other. All right, the next one is 1 and 3. So angle 1 and angle 3. These are what? Those angles are corresponding, sorry. They are on the same side of the transversal. Notice they're both on the left side, and they're above that. They're on the left side of the lines, and they're on the above the transversal, okay? So they're same. So I'm going to write same here just to help y'all remember. Same, comma, same. And these are corresponding angles. Okay. Then we got 3 and 6. So let's look at 3 and 6. So 3 is here and 6 is there. So these are on alternate sides of the transversal and on opposite sides. So we're going to say alternate and opposite. Alternate sides and of the transversal and on the inside, alternate inside, or same. No, yeah, let's say inside the parallel lines, okay? Okay, so this is alternate interior, inside interior. So alternate interior angles, okay? So I'm going to keep going. So the next one is 4 and 5. So angle 4 and angle 5. So notice where these are. Those are also on alternate sides of the transversal, right? And they're on the outside, right, of the parallel lines. So these are alternate exterior lines, okay? Alternate exterior angles. Okay? All right, let's look at the next one. So the next one is 6 and 7. So 6 is here, 6 is there, and 7 is there. So those are on the same side of the transversal and inside. So same and inside, right? So if it's same side and inside, then that's going to be same side interior, okay? So these are same side interior angles. Okay, and now our last one is going to be 5 and 8. So 5 and 8 are again on the same side of the transversal. So this is same side, right? And then what? Outside our parallel lines, or our lines. Outside the two lines, right? So same outside. So these are going to be same side exterior. So you can use just where they are to name them, okay? So when parallel lines are cut by a transversal, the pair of angles formed are either congruent or supplementary, and that's what we're going to talk about next, okay? Are they congruent or are they supplementary, okay? So we're going to talk about that in a minute. So look up here. So now, on this one, so we've got our postulate. So this is corresponding angles. So notice that 1 and 3, same side of the parallel lines, and on the top, so same. So this is what I always say for this. This is same, okay? Same side of the transversal and same side of the parallel lines, okay? So, and look at the angles, okay? Y'all see this 1 and this 3 right here? They're both what? They're both obtuse angles. So the corresponding angles are always going to be congruent, okay? So that's what you're going to put there. So, so 2 and 4 are congruent, 5 and 7 are congruent, 6 and 8 are congruent. All right. So the next one is alternate interior angles. So we have 2 pairs of parallel lines, right? So look here again. So we've got our 1 and our 3. Those are our pair of angles that are alternate interior. So they are alternating sides. So I'm going to say alternate and interior, right? Inside, alternate and inside. So they're inside the parallel lines. Okay, so notice again, these are congruent, right? So 1 and 3 are congruent and 4 and 2 are congruent. Do you notice that? 4 and 2 are also congruent. So these are, again, opposite sides of the, or alternate sides of the transversal and inside the parallel lines. Okay, so these are going to be, again, congruent, okay? So just look, obtuse, acute, acute. Do you see that? Okay, so now when we talk about alternate exterior angles, we're going to talk about, again, we've got our 5 and our 7. So again, these are on alternate sides of the transversal, left and right, and then outside, right? So these, again, alternate and outside. Okay, so again, these are congruent as well, okay? So then when we talk about same side interior angles, okay, so same side interior angles. So again, this is same side of, so this time we're talking about 1 and 4. So those are on the same side. See that? Now, notice this time they are not congruent because one's obtuse and one's acute. So this is again going to be same and then what? Inside. Okay, those are your terms. All right, so same side and inside. So this is going to be, when I add those together, they're going to equal 180 degrees because one's acute and one's obtuse. And these are the types of relationships that are always going to exist. They're either going to be congruent or they're going to be supplementary, okay? So now look at the same side. Exterior angles again, so 5 in and 8 are same side of the transversal and what? Outside. So same and outside. Okay. And so then again, notice that one's acute and one's obtuse. If that's the case, then they're going to be equal to 180 degrees. Okay. So now what I'd like you guys to do, actually, we're going to walk through this one together. So it tells us that the measure of angle 1 is 140 degrees. Okay. So then what would be the measure of angle 2? Do you notice that these two form a linear pair? Okay. So that means we're going to go 180 minus the 140, and that's going to equal 40 degrees. Okay. So let's talk about, now that we know that this is 40 degrees, what else can we say? Do you see the vertical angles? What is the vertical angle to angle 2? These angles are congruent, aren't they, guys? Because they're vertical angles, so that means this one's 40. And notice again that these are also congruent, right? So I'm going to do 2 arcs here, so that's 140 as well. Okay, so we now have 3 and 4. So we have that angle 3 was 40 degrees because it was a linear pair. And we have, a vertical angle to 2. And then 4 was 140. Why? Because it was also a vertical angle to angle 1. All right, so now let's see what we can figure out next. So there's a couple ways we could find number 5. We could say that there's a corresponding angle to number 5. So do you notice that this angle here and this angle here are corresponding angles? They're on the same side of the transversal, and they are on the same side of the parallel line. So this is 140 degrees because it's a corresponding angle, right? And then 6 is a linear pair again. So if the other one was 40, then this one has to be 40, right? And then we can work through the rest of this the same way. 7's a vertical to 6, and 8's a vertical to 5. Y'all see that? Okay, so we can go ahead and fill this out, the rest of this. So this was 40 degrees, right? And 7 was 40 degrees. And 8 was 140 degrees. Now you should notice that all of these angles are the same numbers, basically, essentially, either 40 or 140, okay? When the lines are parallel. Oh, let me show you something else I have not communicated to y'all yet. So how do I know these lines are parallel? They have arrows on them. So that's what's going to indicate to me that these two lines are parallel, okay? There's going to be a set of arrows on the line. Very, very, very important. Because these angles are not guaranteed to be congruent or supplementary unless the lines are parallel, okay? So sorry, I forgot to say that earlier. All right, so here again, in this drawing, let's go ahead and draw this. It should have been there that these are parallel, okay? So draw those parallel symbols on M and L first. Then you can find for me the measures of all the angles. So pause the video and come back to me when you're done. All right, so it tells us that the measure of angle 3 was 70 degrees. So that means we know 1 is 70 degrees, right? How would we find 2? So this was going to be, what, 1? So that was 70 degrees. So let's just go ahead and find angle 2 now. So wouldn't we find angle 2 by taking 180 minus 70? And wouldn't that be 110 degrees? And does it look like an obtuse angle? It does to me too. So that's 110, which means what else? 4 is 110, right? Because again, it's a vertical angle, okay? So 110 degrees there. All right, now what else can we do? So do you see that 71 and 5 are corresponding angles? Y'all see this right here? 1 to the left and below, 5 to the left and below. So that means that angle is going to be 70 as well, right? Which means 70 is going to be 7. And then 6 is going to be 110, and 8 is going to be 110. Okay, y'all see that? So that means angle 5 is going to be 70, and 7 is going to be 70, and 8, let's just go 6 is going to be 110, and 8 is going to be 110. Okay? Any questions on that one? All right. So now, example 3 says, identify the angle measure and postulate theorem used to prove that the angle measure So line P and Q, line Q are parallel. This symbol right here, look right here, y'all, this line symbol right there, that means that the lines are parallel. So it could have just said P double line Q, and that tells me that P is parallel with Q. So once again, we're going to draw an arrow on there because that's what indicates that those lines are parallel. So it's asking us what's the measure of angle 6. So it told us that the measure of angle 2 was 88. So we're going to write 88 right here. And so that means that we can then work through some of these, right? So what is the relationship between angle 2 and angle 6? So right there's angle 2 to the left and above. And do you notice this one right here? Angle 6 is to the left and above. So isn't that corresponding angles? So what do we know about corresponding angles? And here's the hint, guys. Notice that that angle is on the same side of the transversal and the same side of the parallel lines, right? So corresponding angles are congruent. So that means this is also going to be 88 degrees, isn't it? So then the measure of angle 7. So let's go ahead and put this 88 over here. Okay. So now what do you notice about 6 and 7? What kind of relationship is there between 6 and 7? We're looking at angle 7 now. Now, don't angle 6 and 7, aren't they opposite each other? So that means this is also going to be 88 degrees, but why? Because they're vertical angles, right? Okay, so we're going to say vertical angles. All right, then we got 8. Okay, so we could use either 7 or 6 to find 8, but what you should notice about 8 is, and I'm going to draw it, 8 is right here, right? So notice these two angles, don't they form a straight line? So to find this one, couldn't we do 180 minus 88? And isn't that going to be equal to 92, I think? $92 degrees, right? So this is 92 degrees because why? What do we say? These are a linear pair, right? So we could use linear pair. Honestly, we could have also used what? We could have used same side exterior angles, right? Because 2 and 8 are same side exterior. So we use linear pair. You could have used same side exterior. Either one of those, right? So all of these we could have used the fact that they are, and then also with number, so if we were to use angle 2, let's just talk about angle 2 for all of these. So this could have been the measure of angle 2, right? And if we were to talk about the measure of angle 7, let me erase this off of here, the measure of angle 7, as it relates to the measure of angle 2, aren't those alternate exterior angles? So we could have also said here, alternate exterior angles, okay? And that would have been the measure of angle 2, right? And then if we were to relate 8 and 2, so again, we're going to take it back to our original, 8 and 2. So 8 and 2, those are same side exterior. And we already talked about that one, okay? So that could also relate them back to the measure of angle 2, okay? So all of them could have been solved with the measure of angle 2. That's all I'm trying to show y'all. There are multiple ways to do problems in algebra, in geometry, okay? So now, I'd like you guys to solve these and tell me what you think the answers are and why. So what is the relationship between this angle and this angle? So it would be alternate sides of the transversal and interior, right? Inside, you notice they're inside the parallel lines. And we know they're parallel because they have triangles on them. So this is going to be 128 degrees as well, right? Okay, now let's talk about this one over here. So we've got the 47 and the question mark, right? So this time we're going to have to do a little math because those angles don't look the same, right? One's obtuse and one's acute. So the hint to me here is that they have to add up to be 180 degrees. So I'm going to subtract 47 from the 180. And when I do that, I get 133, okay? So the answer was 133. And I'm going to put it up here. Because again, when I add those two together, they have to equal 180. And these were same side, aren't they on the same side of the transversal? And what? Interior. So these are same side interior angles, okay? All right. Let's see if you guys can do these 2 U tries, actually 4 U tries, A, B, C, and D, and then come back to me when you're done. So let's talk relationships here again. So we've got this angle and this angle. So those are a linear pair, right? So we're going to have to do some math again. So this is going to be 180 because a line equals a 180 minus 130. So that's going to be 50 degrees, right? So that's going to be 50 degrees. and, yeah, where'd that go? It's a linear pair, right, because they form a line. Okay? All right, the next one. What is the relationship between this angle and this angle up here? They're on alternate sides of the transversal, so that's alternate. And they're inside the parallel lines, right? So it's alternate interior angles. And then what can we say about those angles? They are congruent, right? So that's 92 degrees. All right, so the next one. We've got the 105 and the question mark again. So these are vertical angles, aren't they? And what do we know about vertical angles? They are congruent, right? So all we have to do is put 105 here for that one. All right, here's our last one, 46 and question mark. So these are on the same side of the transversal and the same side of the parallel lines. So they are going to be congruent, right? So this is going to be 46 degrees, right? And that means they are corresponding angles. Okay, corresponding means in the same place, okay? All right, so here's our example 4. What is the relationship between the two angles? It says to find the measure of each angle. So the first thing we want to do is figure out what the relationship is. So we're looking for ECF. So where is ECF? Is down there, right? So is there any angle that we could use to find ECF? Well, I noticed that I have the measure of GBC. Do you notice that? So this is equal to the measure of GCBY, because they're in corresponding positions, aren't they? Do y'all see that? Okay, because they're both below the transversal and to the right of the parallel lines. So same side, same, right? Okay, so that means the measure of angle ECF is going to be our 70 degrees, isn't it? Is equal to 70 degrees. Again, why? Because they're in corresponding positions, okay? Then it asks us for the measure of DEC. So where is DEC? So let DCE is right there. So look, before I even do any math to find out what X is, I can actually, do you notice that the 70 degrees below it in the DCF or DCE are a linear pair? So I'm going to write linear pair here. Okay, and because they're a linear pair, I know that those two angles have to add up to be what? 180 degrees, right? So that means I can say that 180 minus 70 equals 110, right? So that is the measure of, sorry, I can't write today. That is the measure of that angle. It's what it's asking us. So yes, we could do some math to get this, but do we have to? No. Now there's another way to do this. Remember I told you in geometry there's multiple ways. So this angle and this angle are corresponding angles, right? So we could say 4x plus 22 equals 5x. Subtract the 4x from both sides. So that's going to give us 22 is equal to x. And then we could plug that back in there for DCE, right? So that would be 5 times 22, and that's still equal to 110 degrees. So no matter which way I do it, I get the same answer. So here's our you tried. I'd like you guys to do this and then come back to me when you're done, okay? All right, so where is EDG? So EDG is right there. So what do we have that would be have the same measure as EDG? Okay, do you guys notice this angle? Acute, right here? Those two angles? What is the relationship between those? Aren't those alternate exterior angles? What do we know about alternate exterior angles? They're congruent, right? So we know that this angle, that measure down here has got to be 75 degrees. You see that? So again, we know that this is equal to 75 degrees. Then, again, it's asking us for BDG. So BDG is right there. So that's that X measure, right? So once again, what do we know about these two angles right here? They are supplementary, right? They form a line. So we can say 180 minus 75, that equals 105. So these were vertical angles. That's what we use. Now there's a variety of ways of doing this again, right? So we could add together these two angles, this angle and this angle, right? and set them equal to 180 because, again, those are supplementary. So if we did that, 2x minus 135 plus x equals 180, right? We could do that. We could also have set this angle equal to that angle, right? Sorry. No, we were trying to find BDG. So we were trying to find this. Okay, so we could set that angle equal to find the x, but that would be too complicated. So let's just do it this way. 2x plus 3x, 2x plus x is 3x, so 3x minus 135 equals 180. Then we add the 135 to both sides, so that would be 3x equals, what is that going to be? 3, let me see, that's 5, that's 11, that's 315, right? Divide both sides by 3, so x is equal to 105, which is exactly what we got, okay? So again, there's more than one way to do this, so that's a good way to check the answers. So this you try. Let's see if you guys can do this one. This is our last one, okay? Let's do this and come back to me. So we're talking about this angle and this angle, okay? So what do we know about them? They're alternate sides of the transversal, interior, inside the parallel lines, right? So we know that they're congruent. So we can say 2x plus 10 is equal to 3x minus 15. This time we had no measure, so we're actually going to have to solve the problem this time, right? So we're going to subtract 2x from both sides. So that's gone from there. So we have x equals, and then we're going to add 15 to both sides. Right? So that's now gone from there. So that's 25. So now it's asking us to find both measures, right? Or actually find A, B, D. So A, B, D is that angle right there. So we're going to go 2 times 25 plus 10. So that's going to be 50 plus 10, which is equal to 60 degrees. Now, if I want to check this, I could plug that in the other one too. So up here, I could say 3 times 25 minus 15, that's 75 minus 15, and that's 60, right? And so that's how I can check my answer,